Hello everyone, my name is K. Srinityam, bearing roll number 458. Today I am going to discuss about the topic Programmable Logic Array, in short form PLA, from the subject Switching Theory and Logic Design. Today, Programmable Logic Array theory and implementation are discussed. Explore the foundational concepts and practical applications of programmable logic arrays. This is the introduction to digital logic and combinational circuits. Binary processing. Digital system process information using binary digits, zeros and ones, forming the core of all modern computing. Output from current inputs. Combinational logic circuits generate outputs based on purely on their current inputs, lacking any memory elements. If inputs are there, so output are coming from the present inputs. Based on the inputs, outputs are formed. Here, key examples. Common examples include encoders, decoders, and multiplexers, essential components in digital design. These are the main examples of combinational circuits. Using combinational circuits, encoders, decoders, and multiplexers, essential components in digital designs, are designed. Efficient implementation. The Programmable Logic Array (PLA) is specifically designed to implement these combinational logic functions with efficiency. This is the main introduction to digital logic and combinational circuits. What is a programmable logic array (PLA)? Programmable device. Programmable device means it is a device. A PLA is a versatile programmable logic device used to implement complex combinational logic functions. Dual programmable planes. It features two distinct programmable sections, an AND gate array following by an OR gate array. These are logic gates. By using these two logic gates, we can program the PLA. Targeted implementation. Unlike read only memory (ROM), a PLA only implements the specific minterms required rather than all possible combinations, making it more efficient. Flexible and reconfigurable. PLAs offer significant flexibility, allowing for reconfiguration before use to create custom logic designs. It means before using the all features of PLA and flexibility, allowing for reconfiguration before use. These are the main limitations or conditions for the programmable logic array. Architecture PLA or PLA architecture. Block diagram overview. This block diagram tells about the PLA. This block diagram uses AND gate and OR gate. Here the inputs given AND array and using OR array. By using AND and OR, outputs are produced. Here the input is and outputs are produced from OR array. Here input buffers. Inputs are fed through buffer inverters, providing both the true uncomplemented and complemented signals to the AND plane. Second, programmable AND plane. This plane is responsible for generating various product terms and functions of inputs based on programmed connections. Here, another program is OR plane. Following the AND plane, the OR plane sums selected product terms, forming the final output function. Optional output complementation. The outputs can be optionally complemented, providing additional flexibility in logic implementation. In simple words, here input is given as AND array, and by using AND array, OR gate selected the plane sums and product sums by forming the final output function. Here the main input is and OR gate uses the AND gate and form the product terms to form the final output functions. Here programming a PLA. How it works? Here programming a PLA involves configuring the internal connections within its AND and OR planes to achieve desired logic function. These connections are typically represented by black dots or fuses. Express functions in SOP form. Here SOP form is as sum of products. Begin by expressing all desired logic functions in the sum of products SOP form. Minimize SOP. Minimize the sum of products expression to reduce the total number of product terms required. Optimizing the PLE uses programmable end plane. Configure the connections within the end plane to generate each of the minimized product terms. Program OR plane. Set the connections in the OR plane to sum the correct product terms of each individual output function. Configure output inversion. If specific outputs require inversion, configure the output stage accordingly. This is the working of the programming a PLA. Here the example implementing functions using PLA. Let's consider a simple example with the three inputs A, B, C and two output functions F1 and F2 defined as output function F1 is equal to AB plus AC complement. Here another output function F2 is equal to BC plus AC. First, identify the product terms. The unique product terms needed are AB, AC complement, BC and AC. Next, program underplane. The underplane programmed to generate these four specific product terms. Next, program OR plane for F1. For F1, the OR plane connections to the product terms of AB and AC. Because AB and AC terms are belongs to first output function F1. So these terms are written in the function F1. Here program OR plane for F2. For F2, the OR plane connection to the product terms of BC and AC. Because BC and AC are belongs to the function second output function F2. Here the advantages and limitations of programmable logic array. Here the main advantage of PLA is high flexibility. Both and or arrays are programmable, allowing for highly customized logic implementation. Here another advantage of PLA is efficient multifunction support. Excellent for implementing multiple distinct logic functions within a single device. Here last advantage of PLA is reduced chip count. By integrating complex function, PLAs can significantly reduce the number of discrete chips required in a system. These are the advantages of limitations of PLA. First advantage is high flexibility and another is efficient multifunction support and reduced chip count. These are the limitations about the PLA. First limitation is programming complexity. More complex to program compared to PALS due to the dual programmable planes. This is more complex than PAL. PAL is programmable array logic gates. Here, another limitation increased propagation delay. Having two programmable planes introduces a large signal propagation delay. If we introduce two signals at a time, their propagation delay is increases. So these are the main limitation about the PLA. Here the another limitation. Scaling challenges. Not ideal for very large scale integration VLSI designs where modern FPGAs offer superior density and performance. These are the advantages and limitations of the PLA. We are discussing about PLA, Programmable Logic Array. The theory, what is introduction about the PLA, examples of the PLA, advantages, limitations. This PLA is very useful for many things. Thank you.